Hi everyone. So in this video, we're starting a new section in the book about logarithmic functions. And so we're not going to get to the function part until the next video. In this video, we're going to be focusing on logarithms. So figuring out, what is a logarithm and how to evaluate different logarithms. So logarithms are something that you are supposed to have seen before taking this class. So I know that if you took Math 98 at North, you've learned what logarithms are, but it's one of those topics that students, I think, always struggle with a little bit. So I think it's really worth going over them thoroughly and making sure that you understand how logarithms work before we build on that to talk about logarithmic functions. Okay, so I want to start by just giving you a definition of what a logarithm is. And I want to warn you up front, this definition is probably going to seem a little confusing. So this is one of those things that when you write down the definition, I think it makes it seem confusing, but then once you get to examples, I think it will clear things up. But I do want to, write down the official definition first. Okay, so a logarithm is this kind of operation that you do. And so we abbreviate logarithm with the word log. And then anytime you're taking a logarithm, there's always going to be a base of your logarithm. So I'm using the letter B to represent base. So that's going to be some number. And then you're always taking a logarithm of a number or of a variable. And so I'm going to use the letter Y to represent the number that we're taking a logarithm of. So when you take a logarithm of a certain base of a certain number, you get an answer, and that answer is another number. And so I'm going to use X to represent that number. Okay, so what does it mean to say log base B of Y is equal to X? Well, that's just an equivalent way of saying, so I'm going to draw this arrow that goes both ways. This arrow that goes both ways means is equivalent to. So the thing I'm about to write on the right is just going to be kind of a restatement of what's written on the left. So if you have log base B of Y is equal to X, that's equivalent to saying that B to the X is equal to Y. So you can kind of think of these as just sort of equivalent ways of saying the same thing arranged in different ways. So I want to give you kind of another way of thinking about this that personally is the way that I like to think about logarithms. So I like to think about logarithms as kind of asking you to work backwards, asking you a question. So I like to think about if you're evaluating a log with a certain base of a certain number, what is that asking you to do? It's an operation. You have to do something to find what the answer is. And so what it's specifically asking you to do, it's asking you to find a number that's going to be your exponent. It's asking you to find a number X such that B to the X is equal to Y. So again, I think if you're confused, that's totally fine. Once we get to examples, I think this will become clearer. But just to kind of restate it one more time, what's really going on with logarithms is that when you're evaluating a logarithm with a particular base, and you're taking a logarithm of a particular number, you're basically trying to figure out what is the exponent that I would need to apply to the base in order to get the number in the parentheses, right? Because that's what this says. So log base B of Y is equal to a number X, if that number is the number that you would need to raise B to in order to get Y. Okay, so let's do this with some actual numbers because I think that will make things a little bit easier to understand. And I don't know where that H went. So this video, by the way, we're going to be doing a lot of examples. The majority of the rest of this video is going to be examples after examples after examples. So I definitely encourage you, especially after the first few, to pause the video and try these yourself so you can see if you understand how they work. Okay, so the first logarithm that I want to evaluate is log base 2 of 8. So we need to figure out what number log base 2 of 8 is equal to. So again, we want to think of this as kind of a question. This is asking us, what number do we need to raise 2 to in order to get 8? And whatever that mystery number is, that's going to be our logarithm. That's going to be the answer of our logarithm. So what power do we have to raise 2 to get 8? Well, 3, right? 2 cubed is equal to 8. And so that means that log base 2 of 8 is equal to 3. So I'm going to kind of write this below. This is our like explanation for why log base 2 of 8 is equal to 3. Log base 2 of 8 is equal to 3 because 2 cubed is equal to 8. Okay, so let's do another example. Let's evaluate log base 4 of 16. So this time we're trying to figure out what power do we have to take 4 and raise it to get 16. So what exponent would we need to put on the 4 to get 16? Well, it would need to be 2, right? And so the answer to our logarithm is 2 because 4 squared is equal to 16. And by the way, just to mention this, because there's been a little confusion with this in the past when I've taught, your answer for the logarithm is just this number. Log base 2 of 8 is equal to 3. It's kind of like taking a square root, right? Square root, when you're taking a square root of a number, you have to kind of work backwards, right? When you take like the square root of, let's say, 36, the square root of 36, you have to kind of work backwards and think, wait, what number do I square to get 36? The answer is 6. So your answer would just be 6. This part is kind of more like the process. This is how we're like making sure our answer is correct, but the answer itself is just the number on the right. So log base 2 of 8 is equal to 3. Log base 4 of 16 is equal to 2. Okay, what about log base 5 of 5? So this is now asking us, what power would we need to raise 5 to get 5? Well, you would just raise 5 to the first power, right? 5 to the first power is equal to 5. And so that tells us that log base 5 of 5 is equal to 1. And so that's always going to be the case. Anytime you're taking a logarithm where the base is the same number as the number you're taking the logarithm of, your answer will always be 1, right? Because if you're trying to go from this number to this number, you do that by applying an exponent of 1. Okay, one more example before I introduce a little bit of more notation. So let's say we're taking log base 3 of 1. So this is asking us 3 raised to a mystery power is equal to 1. So what number do you raise a number to get 1? Well, you can always raise a number to the 0 power, right? 3 to the 0 would be equal to 1. And so log base 3 of 1 is equal to 0. And that's kind of a good thing to just know in general. Anytime you're taking a logarithm of 1, your answer is always going to be 0. So why is your answer always going to be 0? Well, because any number to the 0 is 1. So if you're trying to figure out how to get that 1, the answer is always going to be 0. Okay, so that's just some basic examples of logarithms. Now we're going to look at a couple more kind of definitions that we need, and then after that we'll look at some slightly trickier examples. So these are going to be some special types of logarithms. So there are two special logarithms that just happen to come up a lot in, especially in the sciences. And so because they are special, they have a special name. So if you ever see LN, just like that, without a base written, without the word log, it's just literally the letter L and the letter N. This is an abbreviation, or it's shorthand, for log base E. So if you're taking a logarithm with a base of E, so remember we learned about E in our last video, we learned that E is just a special number, it's about 2.72. And whenever we're talking about the number E, because it has infinitely many decimal places, we don't try to write the whole number down, we just use the symbol E to represent it, kind of like the number pi. And so when we're taking a logarithm with a base of E, instead of writing log base E, we write ln. And then the other one is if you just write log without writing any base to it, that is a shorthand for log base 10. So, if you want, you can like rewrite, when you see them, rewrite it as log base e or log base 10, but just know that no one writes them like this or like this. That's why the shorthand exists. It's so that we have a special symbol that's a little shorter to write for those. So let's do a couple examples with these ones. So for example, let's say you wanted to take ln, sorry, I forgot which one I was doing, ln of e squared. So let's evaluate this logarithm, same way we did the ones on the other page. So remember again that ln is just shorthand for log base e. And so, on these other examples, how are we approaching them? We were kind of looking at, okay, here's the base. We're trying to figure out what number we have to raise the base to get this number. It's the same deal. It's just that we don't have that base actually written down. So in this case, we're trying to figure out what power do we have to raise e to get e squared. And it's almost kind of a silly question, right? Like what power do you raise e to get e squared? Well, to the second power, right? So the answer here is actually just 2, because e squared is equal to e squared. So I know it's kind of a weird example because it's almost like too straightforward, and that kind of almost makes it more confusing. But yeah, so ln of e squared is equal to 2 because ln is just asking us what power we have to raise e to get e squared, and the answer is 2. Another example would be log of 1,000. So this time, working with log, that is this special logarithm with a base of 10. So this is asking us what power do we have to raise 10 to get 1,000. And so the nice thing about powers of 10 is that every time you multiply 10 by itself an additional time, you get an additional 0, right? So 10 to the first power has 1 0. 10 squared is 100, that has 2 zeros. 10 cubed is 1,000, which has 3 zeros. And so the answer to this one would be 3, because 10 cubed is equal to 1,000. But yeah, you can kind of think of log as measuring how many zeros a number has, right? So if this was 10,000, that would be 4 zeros, and the answer would be 4. If it was 1,000,000 that has 6 zeros, the answer would be 6. And that's just because, like I said, every time you multiply 10 by itself, an additional 0 is tacked on. Okay, so I want to now do a few examples that are a little bit trickier. So these are going to bring up some of the exponent rules that we actually discussed in an earlier video, or in our first video about exponential functions. We talked about about how fractional exponents work and how negative exponents work. And so those are going to come up now in this portion. Okay, so first one I want to do is log base 3 of 1/9. So just like on the earlier examples, this is asking us to find an exponent, right? We're just trying to figure out what power would we have to raise 3 to get 1/9. So remember that, what is the type of exponent that gives us 1 over something? Well, it's negative exponents, right? So if we were to raise 3 to the -2, that would give us, and I'll even write this out in a little more detail, that would be the same as 1 over 3 squared, right, which is 1/9. And so our answer is -2. So the answers to logarithms can be negative numbers, and that usually occurs when you have something like this, where it's like 1 over a number. Okay, so next one I want to look at is log base 25 of 5. So this is now asking us, what power do we need to raise 25 to get 5? Which at first seems a little weird, right? Doesn't it seem like it should go the other way? We know that if you take 5 and square it, that gives you 25. But what power do you raise 25 to get 5? Well, remember that you can take square roots using exponents, right? So specifically, if you raise a number to the 1/2 power, that is going to be the square root. So 25 to the 1/2 would be the square root of 25, which is 5. And so the answer to this logarithm would be 1/2. Okay, so as I said before, I definitely encourage you at this point, we've basically gotten all of the different types of scenarios that could happen out, so I'd really encourage you on these next few to pause the video and try these yourself. So log base 8 of 2. So this one is asking us what power do we need to raise what power do we need to raise 8 to in order to get 2 as our answer? So this is similar to the last one, right? The last one, it was kind of weird. It felt like, we wanted to kind of go the other way, right? We know that 2 cubed is 8. Well, that means that the cube root of 8 is 2, right? And so how do we write a cube root as an exponent? Well, we can write it as 1/3, right? 1/3 would be a cube root. So I'll write that out. So 8 to the 1/3 would be the cube root of 8, which is 2. And so that means that the answer to our logarithm is 1/3. Okay, so next up, let's do log base 4, actually, of -16. So this one is asking us, what power would we need to raise 4 to in order to get -16? So this is actually kind of a trick question. So you might guess -2. Right? Because we know that 4 squared is 16. You might think, oh, 4 to the -2. But 4 to the -2 is not -16, right? 4 to the -2 would be 1 over 4 squared, which is 1 over 16. And that's not the same thing as -16, right? Those are two completely different numbers. And so that tells us that the answer is not -2. So what number could we possibly take 4 and raise it to and get -16? Well, there is no number, right? You can't take 4, think about what it means to raise 4 to a power. There's no way that you're ever going to get a negative answer by multiplying 4 with itself or by doing, 1 over 4 to a power. You're never going to get a negative answer. And so this one would be DNE, or you could say no solution, undefined. It just doesn't exist. So this one does not exist because there is no, let me kind of write it this way, because there is no number x such that 4 to the x is equal to -16, right? We couldn't figure out any exponent that could go there, and so that tells us that this logarithm is undefined. It doesn't have an answer. And so you cannot take a logarithm of every number, and we'll talk more about this in our next video when we get into talking about logarithmic functions. But for now, just be aware that it's not always going to give you an answer when you try to take a logarithm. It's kind of like how you can't take the square root of a negative number, right? It's a very similar idea. Okay, so this is asking us log of 1 over 1,000. So what does log mean? Well, we know that's a base of 10. Right? So we're trying to figure out what power would we need to raise 10 to get 1 over 1,000. Well, in an earlier example, we talked about how 10 cubed was 1,000, right? And so in this case, we don't have 1,000, we have 1 over 1,000. And so that means that we need to put a negative exponent. And specifically, we would want to put -3. So why would -3 work? Well, because -3 would give us 1 over 10 cubed, which is 1 over 1,000, which is what we were looking for. And so our answer is -3. Okay, couple more examples. So let's try ln of 1. So again, ln is a special type of logarithm, and it's specifically a logarithm with a base of e. So it's asking us, what power do we need to raise e to in order to get 1? So just like in an earlier example we did, we saw that any number raised to the 0 is 1, right? And so it might seem a little funny because of the e, but remember that e is just a number. E is like any other number. It works like other numbers. When you raise it to the 0, you get 1. And so ln of 1 is asking us, what power do we need to get 1? And the answer is 0. Okay, what about log base 3 of 0? So this is asking us, what power do we need to raise 3 to in order to get 0? So this is actually another trick one, right? There's no number that you can raise 3 to and get 0. You might guess 0, right? That might be your first kind of intuition here, but we already know that 3 to the 0 is 1. So if this was asking you for log base 3 of 1, the answer would be 0. But this isn't asking you that. It's asking you what power you have to raise 3 to get 0 as your answer. And that's just never going to happen. There's no number that you can take 3 and raise it to and get 0 as your result. And so just like the one with the negative, this one does not exist. So a lot of people will mix up this one and the previous one. So you can take a logarithm of 1 and your answer is 0 because any number to the 0 is 1. You cannot take a logarithm of 0 because you can't take a number and raise it to a power and get 0 as your result. Let's do just one more. So let's do ln of square root of e. So this is asking us, what power do we need to raise e to get the square root of e? So again, this is one of the ones that I think is actually in some ways easier, but there's something that just seems more confusing about it. But we know how exponents work to give us roots, right? So we know that in order to get a square root, we need to raise it to the 1/2 power. And so e to the 1/2 is equal to square root of e. And so our answer is 1/2. So far we have been focusing on evaluating logarithms, right? We've been taking a logarithm that has a number as its answer. But one other thing that is going to be useful to know how to do is to go back and forth between logarithmic and exponential form. So I want to do a couple questions like that. And I'm also going to show you how to do them on your homework. So there's a couple of these on your homework, and the way you enter your answers in is a little bit weird. So I just want to show you how to do that as well. Okay, so the first one is asking us to express log base 3 of 5 is equal to x as an exponential equation. So I want to be clear, this is not asking us to solve anything. We're not going to have an answer that's just a number. It's not asking us to evaluate. What this is asking us to do is to write down an equation that would be equivalent to this equation that's written down. So going back to the first page, where we wrote down our definition of logarithms, this is really what we're going to be using here, right? So at the very beginning, we talked about how if you have a log with a certain base of a certain number, if your answer is another number, well, then you can say that that's equivalent to raising that base to your answer and getting the number that was inside the parentheses. And so we're just going to apply that kind of rearrangement in order to get our answer on this. So going back to what we're looking at here, well, we know that whatever number is your base in the logarithm, that's going to be your base in the exponential equation. So it's going to be here. And then whatever number is your answer from the logarithm, remember that when you're evaluating a logarithm, you're finding an exponent, right? And so your answer in the logarithm is your exponent. And then that leaves the number that is on the inside here to be the right-hand side of the equation. And that's it. That's all this is asking you to do. It's asking you basically to apply that definition to rearrange things. Okay, so this one is asking you to go the other way. So it's asking you to start with a exponential equation and rewrite it as a logarithmic equation. So again, we know that the base is going to be the same, right? So the number that's the base of your exponent is going to be the base of your logarithm as well. And so another thing we can kind of think of here is the exponent is always going to be the answer for the logarithm, right? We know that when you're evaluating a logarithm, your answer is the exponent. And so that tells us that x is going to be on the right side. And then that leaves us with 9 here. And that makes sense, right? Because when you think about logarithms, logarithms are trying to get you to go from this number to this number by using this exponent. And that's exactly what we have written here, right? We have 2 to the x is equal to 9. So I just want to quickly show you how to enter your answers in on the homework that asks you to do these, because it's just a little bit funny with the way it's formatted. So I'm just going to pull that up. Okay, so this one is asking you to go back and forth between, it's asking you to start with logarithmic form and then rewrite it in exponential form. So notice how the boxes are kind of arranged in this funny way. That's because you're supposed to put the base here, the exponent here, and the answer here. So for this one, our base would be 7, right? So we would put a 7 into this first box. So we'd say 7 as our first exponent, and then the answer to the logarithm is your exponent, right? And so we put n in this box, and actually I should make it lowercase. And then that leaves us with the number 6 to go in this box. So it's really just asking you to do the same thing we just did, but again, the only thing I want to point out is that I think these boxes might look a little confusing, but it's just meant to kind of force you to put, this number to this power is equal to this number. Cool, we got it right. This one's asking you to convert to logarithm. So notice it already says log. So you're going to put the base of the logarithm down here. Then you're going to put the number that goes inside the logarithm here, and then you put the answer here. So hopefully that's not too confusing. But yeah, that is it for this video. Like I said, in our next video, we're going to take this idea of logarithms and bring it into talking about functions that use logarithms. So I'll see you all in the next video.